Spectrophotometry is a method to measure how much a chemical substance absorbs light by measuring the intensity of light as a beam of light passes through the sample solution. To begin this lab, you must already have 5 solutions made. One solution will be a copper amine. 3 other solutions are a series dilution from the initial stock, which is the copper amine. The final solution should be the unknown solution, which is what you are testing for in this lab. Using your 5 solutions, you will need to place some of each solution into a cuvette to go into the spectrophotometer. You will also need to prepare a water cuvette to zero the spectrum before testing the other dilutions. The reason you zero with the water before testing the other dilutions is to negate the water molecules that can interfere with the other tests. When filling the cuvettes, you should use a plastic dropper to transfer your solutions and your water, and your meniscus should touch the line that is marked on each cuvette. You should repeat this process for each solution, remembering not to put too much or too little. Before placing any cuvette into the spec, you must wipe them down on both sides that has the arrows on them to avoid any cloudiness within the readings. Then you will place the cuvette into the spec with the arrows placed horizontally. For the initial water cuvette, you will need to click the 0 button on the computer after placing the cuvette into the spectrophotometer. Then, with all the other readings, you must clean and place them into the spectrometer, and you must press read on the computer. Once you have gathered all of your information, you should be able to come up with a graph like this one that tells you the correlation between concentration and absorption. You will use this graph to figure out what your unknown concentration is, and you will then be able to tell what your unknown is. The linear equation that we are given is determined by Beer-Lambert's law. This law declares that the relationship between the concentration of a solution and the absorption of a solution is linear. To determine the absorption of a solution, we must use the linear equation y equals ms plus b, but as A equals epsilon s plus b. In this case, A is absorbance, which you gather from your spectrum, E is epsilon, or the slope, x is the concentration, and b is the y-intercept, or the given. That's determined from your graph. During this lab, you must note that we are scanning across all wavelengths in order to determine a range of useful wavelengths that classifies our absorption of our unknown, which this can work hand in hand with determining the specific wavelength, or the lambda max, which is where the solution is best absorbed. Lambda max refers to the wavelength in the absorption spectrum where the absorbance is maximum. Generally, molecules absorb in a wavelength range centered around the lambda max. Once you are done with all your work, don't forget to clean up.